This project began with a question. Can I use ultrasonic sensor to detect an object? Well, yeah. Ultrasonic sensor is a rangefinder. It can't tell where that object came from. But at the same time, the sensor also look like a pair of googly eyes or binoculars. So surely there's a way to make it work. And as it turns out, it is possible to make an ultrasonic sensor tell where an object is. But then what's next? Having a sensor just blankly staring at your face is boring, to say the least. So the ultrasonic sensor is a particularly long range, so it's going to be close and personal. So why not make it physically beat the target to death? The project picked up from there. In its final form, the Slapper machine is an Arduino-operated turret that uses a sweeping ultrasonic sensor to determine both range and bearing of a target, like your hand. If that object dare come close enough, it will slap that object to oblivion. Otherwise, it will patiently wait. And as a cherry on top, there is a potentiometer that will adjust the speed of the slapping, so you can decide how hard you want it to beat you up.
Alright, let's take a look at the components we are using for this project. First, we have two SG90 servo motors, one for slapping and one for aiming. Then we use an HCSR04 ultrasonic sensor to detect the distance of the target. A potentiometer is used to control the power or speed of the slap. And finally, because the Arduino board does not provide enough current to power two servos, so we are using an HD42 power module as an external 5V power supply. Now, let's talk about the circuit wiring. As usual, we start by connecting the ground and 5V rails to power the basic components. Next, we connect analog pin S0 to the middle pin of the potentiometers. Digital pins 9 and 10 to the trigger and echo pins of the ultrasonic sensor. Pin 11 to the rotating servo. Pin 12 to the zapping servo. Since Tinkercad does not include the HD42 power module, in its library, we simulate the external power by using 5V battery instead. Okay, now I will be explaining the code behind our Arduino-based slap machine. First, we start by including the servo.h library. This allows us to control servo motor easily. Next, we declare two servo objects. First, my servo controls the aiming mechanisms. The next one, the slappers, is the actual slapping hand. For the post, this variable tags the current servo position when sweeping or slapping. For the power, it stores the slap power levels, which we will set using a potentiometer. For the port pin, is the analog pin A0 connect to the potentiometers. For the logs, this stores the base angle when the target was detected. For max range, define the maximum distance the ultrasonic sensor will consider a valid target. For tick pin and echo pin, their pins connect to the ultrasonic sensor, triggers, and echo pins. For my range, this is the distance threshold for slapping. If something is closer than this, it got slapped. For duration and distance, they are used to measure the time it takes for the ultrasonic pulse to return and convert it into distance in centimeters. Okay, for the setup function, we define the ultrasonic sensor triggers as an output and the echoes as an input. Okay, we set the serial begin to default. Okay, we attach my servo to pin 11, slapper to pin 12. Okay, for the loop function, we call the file. Okay, let's look at the file function. The file function is the scan from side to side to find where the object is the closest. First, we sweep from 10 to 150 degrees and record the base angle where the distance was shortest, and by called sweeping function. Okay, let's look at the sweeping function. The sweeping function is perform the actual scan. We increment move the servo and measure the distance at each angle, and then it updates our reading if the current one is closer, and it will return the after it's scanning both forward and backward, it returns the angle with the shortest distance. Okay, back to the file function. Okay, after we finish for the first sweep, then we do more fine-tune sweeps near the base of angles, making it more accurate. And it will return the bearing. It means return the angle to point the servo toward. Okay, let's look at the loop function. Loop function after we call file. Okay. After we call the file function, that we will get the angle where the target is closest. So, my servo, the right lock, we rotate the aiming servo to that angle. And we enter a loop that keeps running as long as an object is within detection angles. If the object is very close, it's time to slap. So we call the slap function. Okay, let's look at the slap function. Slap function, where the action happens. Slap function first, hover the equal analog lead dot port pin. Okay, we read the potentiometer to get a value from 0 to 1023. We map that to a usable power values. If lower, it means harder slap. Okay, and it moves the slapper forward fast and move it back to the resting position. After we slap, yes, and if the distance is not code yet, so we just spin the distance, and that's all for the coding.
Okay, so this is our slapper. The spoon arm attached makes it look more imposing and scary, even though it has squiggly eyes. You will now power it up, like so. It's now performing the first sweep, measuring the distance along the way. You will know that this is where my hand would be, the angle where the distance will be shortest. I will now do the second sweep around that angle, and we'll repeat that with the third sweep. It's now slapping me. If I adjust the potentiometer, I could make it slap me faster or slower. If I move my hand out, it will hold. If it's not within range of the spoon arm, it will hold. It will not slap my hand. Only when if it loses sight of me, it will try again. It will find me again, which it will do occasionally. The ultrasonic sensor is not very accurate, so sometimes it will do that. So we'll let it try again. Okay, it's now slapping my hand again. Out. Okay, now lose sight of me. So this is our demo of our slapper. And special thanks to this Arduino forum that discuss potential solutions to how a ultrasonic sensor can detect an object. We took the advice and implemented it into our code. So thank you.